So fine guys, let's start. So yesterday we have seen symmetric skewness concepts, right? So let's continue. Okay. So today, if I just show you few distributions, okay. See over here you can see certain data points, okay, and its frequency. Fine. So just to give an idea, guys, most of the times whenever we say a distribution, okay, so most of the times whenever we say a distribution, it is plotted against two things. Outcomes, one is outcome. Second thing is its probability of each outcome. Okay, probability of each outcome. Okay, guys. So here you will have outcomes, like what all outcomes particular event can have. Okay, what all outcomes a particular event can have. And second thing is what is the probability of each outcome. What is the probability of each outcome? Fine. When you, let's say you're having 1, 2, 3, 4 are the five are the outcomes, and probability could be something, right? So if you have 0 0.3, 0 0.5, 0 0.8 and 1, right? So if this is probability of this, and this is probability of this, and this is probability of this, okay, 4 ka probability this, 5 ka probability is this. So now when you join this, so this will become the some distribution of some event. Okay, so usually the distributions probability are drawn against probability distributions are drawn again two things, outcome and probability. Fine. So now yesterday I was showing you a normal distribution, right? Yesterday I was showing you normal distribution. Okay, so we are going to see normal distribution in detail, okay, in upcoming classes. But since we have discussed this topic, I will show you. Usually I'm saying, okay, usually I'm saying normal distribution will look like a bell curve. Agree, guys? I said this will look like this. But why it should look like this, and why something like this is possible? Okay, how, in which cases you will have this? Okay, so I will just give you an idea here. Okay, because as I said, you will be drawing this distribution, this graph, against two things, right? So one is the outcome, and second thing is the probability of its outcome. Okay, so now if at all, let's say my distribution is regarding the age. Okay, age of people. Okay, age of people is my event. Okay, we call it event, and I want to draw the distribution of this. So coming to age, what will be the different categories I can have in age, right? Okay, what are the different categories I can have in age? So I can have 0 to 10, fine, 10 to 20, 20 to 30, okay, 30 to 40, like that, right? 40 to 50, let's say 50 to 60, right? So now you will have, usually if you see, even if you take India, the youth population will be high. Okay, so let's say on overall overall scale of, I would say, of 100 percentage. Okay, overall if the percentage is 100, fine. So the percentage of the youth population, that means 20 to 30 and 30 to 40, will be high, because even if you check the statistics of the, or the survey statistics of the population, most of the people are in the middle age, okay, or young. Fine. So here the probability of the people falling into this age will be high. Okay, and the old age will be, this will be moderate, Okay, this will be moderate, this will be low. Okay, and the newly born might be low, and this will be moderate. Now this is what is the event age. Age is the event which we are discussing. And what are the outcome? Two things. One is outcome, two second is the probability. Now if you see outcomes are, these are the outcomes possible for age. Okay, and these are the probability. So we can convert it into probabilities. Fine. So do you know that all probability, the sum of all probability should equal to 1. Probability can never be greater than 1, and it can never be less than 0. The range will be 0 to 1. Agree? So now we can, I'm just taking this as an example, but you can convert this into certain probabilities. So, but here if you see, if I mark these values over here, so if you mark values over here, so first of all, if I just remove this, and if I am marking like this is a 0 to 10, yeah, this is 10 to 20. I'm just writing 1, 2, 3, 4 because I don't have space. Okay, let's call it as 1, 2, 3, 4, 5, 6. Okay, so let's say 1, 2, 5, 6. Okay, these are different categories. What are these? These are outcomes. Okay, and next thing is the probability. So for one, the probability on here on y-axis, I should tag. Let's say I'm having low, moderate, high. Okay, low, moderate, high. Fine. So one for one, what is it? It's low. Okay. So that means let me put a point over here. Fine. And two, it's moderate. Okay. Two, it's moderate. Three, high. Four, four also, it's high. Okay. Five, it's moderate. Okay. Six, it's low. Okay. Now these are the points plotted for outcome and its corresponding probability. Now if you just try to join these points, okay, starting with the origin. Can you see a normal distribution bell curve sort of diagram? Yes, right? So
Yeah.
yeah, so that's why as I said yesterday, normal distribution is one of the most important distribution, as many of the usual distributions which we see in our day-to-day life, they follow this. Okay, this is just an intro. As I said, we will touch it more deeply, but just I'm saying, as you can see here clearly, when we plot, when we usually the distributions whatever we are seeing, right, so that are plotted against two things. One is you should have the outcome. Whatever you take, let's say you take salary, what are the possible outcomes in salary, and what is the what is the probability of each outcome. Okay, or weight, or anything, what is a score, I mean the CGPA or your percentage academic score, what is the possibilities outcomes and what is its a probability for each. So those things if you start plotting, okay, outcomes on the x-axis and its each corresponding probability on the y-axis. Fine. So then, not, I'm not saying every time you will get a normal distribution, you can get different types of distributions based upon the event you are taking. Okay, but if at all it is symmetric. Okay, but if at all it is symmetric, fine. Suppose let's say this is 1, 2, 3, 4, 5, 6. Okay, these are the possible outcomes. Fine, these are the possible outcomes of this event. And when I draw the distribution, okay, I got a normal distribution. And is normal distribution symmetric distribution, guys, or asymmetric distribution?
Symmetric.
Okay, symmetric distribution. So here if you see 1, 2, 3, 4, 5, 6, so what is the mean of this? It will be somewhere something around like 6.3 point something. Okay, and median, guys, median is also something around 3.5. Okay,
Yeah.
so here if you draw a line, mostly we can see one more time that mean and median will be at the same position for a symmetric distribution. Okay, this is normal, I agree, but still let me call it as just symmetric. Okay, because as we have seen, all normal distributions are symmetric distributions, but all symmetric may not be normal. Okay, fine. So now if it is symmetric, fine, mean and median can coincide. Fine. So this point is important, guys. We will revisit this point and we will discuss more. But remember, whenever we are saying we are drawing a probability distribution, okay, these words you will start hearing many times in this world of statistics. Okay, so you need to have like fundamental understanding, because otherwise it will be just, you will just by heart. Okay, you will think you will understand, okay, what's going on, but it will be difficult for you to understand. Okay, but whenever we are saying the probability distribution is drawn, that means you are drawing, you are considering an event, and we are considering the outcomes of that event, and we are also finding the each and every possible outcome of every outcome of that. Okay, and we are drawing that. Fine. So there are different classes over here. We'll go into see that, but just ignore those as of now. Okay, but as you can see, if you take a simple example, okay, from day-to-day life example, so this is the actual stats. Even if you see the stats also, this will be the scenario. The youth age will be high, okay, and old age people will be low, newly born will be low compared to this. Okay, with this you can see clearly a symmetric distribution, mean and median will be coinciding. Fine. So now if we go to the next concept, see, as you can see, this is some symmetric distributions, and mean and median. Okay, mean and median will coincide over here. Okay, mean is 100, median is almost 100. Okay, histogram of a symmetric continuous distribution. Fine. So now, however, in a skewed distribution, the mean can miss this mark, as we have seen yesterday, right? In a skewed or asymmetric distribution, it can skip because of what? Because of due to presence of some outliers, or because of some some exponential curves. Okay, so it will make sure, it will what it will do, when you see this graph is what, so you can just roughly see this graph is clearly a skewed distribution. And what is the skewness? Is this positive skew or negative skew, guys?
Positive.
Yeah, positive skew. And as you can clearly see in the positive skew, the right hand tail will be longer, and the mean is shifting towards that. Okay, the mean is shifting towards that. Fine. So after that, yeah, so when you have a symmetric distribution of continuous data, the mean, median, and mode are equal. Okay, in this case use the mean. Okay, yeah, uh fine. So now, to answer the question, now we have seen like mean, median, different types of distributions, but which one to use when? Okay, mean, median, or mode. Fine. So which one to use when? Fine. So if you see, we have mean. Fine. So we have median and we have mode. So why we are doing this, guys? The fundamental thing why we are doing is, obviously we need to have one single number which is representing the all numbers, right? So as I said, if you want to get the height of a complete class which is having like 50 students or 40 students, obviously you cannot consider all the heights. You cannot say height of a student, height of second student, right? You want a single number to represent. Fine, you want to have a single number which represents, but that number which is representing, we are checking whether it is a trustable number or is it getting biased or not. Okay, that is the whole concept which we are trying to do. Fine. So, and how you can expand this thought. So each mean which we are considering over here in future classes will be applied to each column, right? Each column you will have a lot of numbers, right? So there, whenever, see, I'm saying, whenever you are having, if you are just having doubt like why we are studying it so much and where we are going to apply, so in real time you will get lot data, and lots of time the data is not proper, right? So there will be a lot of missing data, improper data, etc, etc. So in that case, let's say out of 100, let's say you're having 1000 rows. In that 1000 rows, 100 rows are missing. Okay, 100 rows are missing. So if it is missing, any machine learning model cannot work on a missing data. That means empty, if you have spaces, empty data, okay, if some of the rows are missing, it cannot understand. Okay, it will give error, or even if it works also, you'll have extremely poor accuracy. So obviously you cannot pass incomplete data. You should fill this data, right? Those 100 rows, wherever the data is missing, you should fill that with some number, right? But what number you will fill, you cannot simply fill with 0 or 100 or 1000 or 1 lakh, right? So you should take a proper decision. Okay, but how you can take the decision with this knowledge? Okay, so you will see the distribution of the column. Okay, you can just plot this column. If these are just numbers, right? As I said, as if I take just an example of salary, if this is salary column, right, and 100 employees salary is missing due to some reason, okay, so you can remaining data 900 and sorry 900 columns data, you can just try to plot it. Okay, if you are able to see a, okay, it's more or less normal remaining data, right? So what do you know with the now you know some okay, if it is normal, let's say symmetric. Okay, if the 900 data is more or less symmetric, now you have enough knowledge about the symmetric distribution, right? So you know if it is symmetric distribution, the mean median will be almost same. So of this 900 points, you can take out the mean or you can take out the median. We have seen, right, how to take the mean and median. Just column dot mean, call the function, median, call the function. You'll get that value and you can replace it. So that particular mean, let's say 900, the mean of this 900 value is 120, for example. So since this is a symmetric distribution, you can justify filling these 100 missing values with 120. Okay, so you can answer this instead of simply filling these values with some random variable. You can take a call based upon this distribution, because this is symmetric and mean and median will be same. So obviously mean is the average value, fine. So and if there are no outliers, you can directly say, oh, okay, because of this reasons I am filling with this 120, which is a mean. Okay, but if there are some outliers, okay, if this is a skewed distribution, obviously we have seen median is more robust. It gets less influenced by these outliers, right? So in that case, you can ignore mean and fill with the median, this 100 values. Agree? So once we fill this, now we have complete 1000 values, and then you can proceed for machine learning. Agree? So everything you do will have a direct or indirect application in the ML chapters. Fine. Getting like where you are, where you can use this.
Yes, Santosh.
Fine. So now coming to mean median mode, as we have seen, yeah, if at all it's a symmetric distribution, okay, you can go by mean or you can go by median also, as both will be mostly same. If it is an asymmetric distribution, you need to mostly go by the median, as this is less influenced. Agree? Median is less influenced in asymmetric distribution. And if the data is categorical, guys, if the data is categorical, that means what? Categories. Okay, then you can go with the which category is repeating maximum number of times, and you can use that as a mode. In those places you can use the mode. Fine. So now if you see we have symmetrical distribution of conditions, the mean, median, mode are equal. In this case, use the mean because it includes all the data in calculations. Fine. However, if you have a skewed distribution, median is often the best central tendency. Fine. So the mean, one important thing about mean is it uses all the data in calculations. Okay, this is a plus point, and if the data is skewed, this will only become the minus point, because it will consider outlier also, and it will in these calculations, and that will like result in it shifting from the actual position. Fine. So that's why if it is symmetrical, go for the mean. If it is a skewed distribution, try to go for the median. Fine. Now, when you have the ordinal, data, the mean and mode are usually the best choice. Okay. For categorical data, you can go for the mode. Okay. Fine. So now, next thing what we are going to see over here is the measure of dispersion shows the scatterings of the data. Okay, it tells a variation of the data from one another and gives a clear idea about the distribution of the data. Fine. So the measure of dispersion shows the homogeneity or heterogeneity of the distribution of the observations. Okay, so what is a dispersion? Like how much it is like that fundamentally it's talking about the range of the given data. Okay. Oh, okay, how it is scattered, like what is the minimum value, what is the maximum value, those things we are trying to understand. Okay, So for example, yeah, so the measure of the dispersion shows a variation in the data which provides information like how well the average of the sample represents the entire data. Okay, it also enables us to compare two or more series in regard. Okay, with the help of variation in the data you can try to control the causes. Okay, yeah, you will understand these points when we do some examples. Okay, but here we are going to see two things. So one is range. Range is the most common and easily understand measure of dispersion. Okay, that means what is a dispersion, like what is a range. Okay, range is not this range, this is also calling range, that but I mean what is a spread of the data, right? What is the spread of the data? That means if the range, what is the age uh, values could be what, right? From 1 it could be maximum 60, right? So this is a spread of the data. Okay, so if you plot these values in the space, so you will have, like you can have you can see the shape and form of this, right? So but this range, okay, the 60 minus 1, okay, this is one type of dispersion. Okay, they call this is one type of dispersion. Okay, that is a range. Okay, and range calculation of range is very simple, maximum minus minimum. Okay, fine. Now, but coming to range also, since it is based on two extreme values, it gets affected by the fluctuations. Okay, range is what, maximum minus minimum value. But as we have seen in some examples, in some examples, if you are having 1 2 3 4 5, okay, what is the range? 5 minus 1 4, agree? But if I add 100, this is some outlier. 100 minus 1 what, 99. See, the range is shifting directly from 4 to 99. Fine. So that's why it is important to keep a special eye on extreme observations. That means sort of noise or outliers. So that's why we are going to see in detail like what is an outlier, how you can handle outlier, what are the some plots which we can use to detect outlier. Okay, different ways, different methods we are going to see the outliers. Okay, fine, then you will have very good understanding. Fine. So with this basic understanding, we are now going to study two very important concepts as I have mentioned yesterday. Okay, one is standard deviation. Okay, and second thing is the variance, guys. Okay, but let me know, are we good till this point? What are the concepts which you are studying? Are we good? You guys following? Any doubts? Okay, fine. Looks like no doubts. Fine. So now, if I, yeah. So if you see, the next concept which we are going to study is known as standard deviation. Okay, it is standard deviation and variance, guys. Okay, these two are fundamental, extremely important concepts for any distribution. Okay, so initially, first of all, before going to the formulas, okay, these are simple formulas, don't get scared about by looking these formulas. Okay, but let's try to understand, right, what is variance. Okay, so whatever we have studied till now, so I hope you understood the main concept. Fine, so we have discussed it well and you understood what is the main concept, I hope. Okay, now coming to mean, what is the mean, guys? See what's happening over here. When I'm saying 0, some 1 2 3, let's say 6 10. Okay, now what is the mean of this? Can someone quickly tell me? 6 7 8 9 20 22 22 by 6. What is 22 by 6? 3.6.
5.8, 3.6. Okay.
Okay, so now the mean is what? Mean is somewhere here. 3.6. Okay, now coming to mean, there are different ways. Okay, there are different ways you can denote mean. Okay, you can say x bar is mean, mu is also mean. Okay, usually if at all you are talking about a sample, okay, if you're talking about a sample, right, so as you can see this mu, right, so if you are talking about a sample they will say x bar. Okay, they will say x bar, we'll see what is population, what is sample. Don't worry why it is different. But here this symbol, if you see here this symbol, okay, uh, yeah, so this symbol, if you see, this is mu, that is also mean. This symbol, if you see, this is x bar, okay, that is also mean. Fine. So you can simply say mean, that is also mean. X bar, if you see anywhere x bar, right? So no one will directly actually write mean, okay, they will say x bar equal to something, that is also mean. But this you should understand as sample mean. And usually they will say mu is also mean, but this is a population mean. Fine. So yeah, so just remember these things, and we will see. Now coming back, so now I'm just trying to write it as x bar. Okay, so I'm just considering this as a sample. For example, x bar equal to 3.6. What is x bar mean? Okay, don't get confused. Okay, now 3.6, this is fine. Now think and see, I'm saying mean equal to 3.6, fine. But what is the mean? Mean is trying to take the average of every value and giving us one value, 1 point, to represent all the points. Okay, but if you see, every number might not be equal distance from this mean. Fine. So I'm saying this is trying to take average of all the numbers and give us 1 point. That's fine. But we should also see how much each number is differing from this point. Fine. See, I'm repeating again. Because we cannot consider each and every point. Okay, if we are having only 6, let's say if you're having 1,000 points like this, since we cannot consider each and every point in the given data set, and we want to represent all of these points with one single point, right, for any further calculations, we are trying to find out this mean or median for anything. Okay, as of now, just consider mean. Okay, we are trying to tell that, hey, I'm representing everybody, all of you 10,000 guys now will be represented by this mean x bar equal 3.6. Okay, as an example, that is fine. Okay, we are doing that. But after that, it's also our responsibility to have a look like this guy. Now we are saying, hey, 3.6 is a representation of everybody, that's fine. But how much each number is varying from this 3.6? How far is 0 from 3.6? 1 is from 3.6, 2 is from 3.6, 3, 6, 10 is from 3.6, right? So that you will understand how much every number, okay, how much every number is differing. So that you will also understand one important point, that whether the difference between the number and this mean, okay, what are the values you are getting? So are these equal? Are these equal, or are there any fluctuations in that? Fine. So if there are any fluctuations, then it will speak something about, right? See, for example, if you see 0, 1, I'll take simple example. Okay, 1, 2, 3, 4, 5, right? So you'll have a mean of 3. And if you start calculating how much each and every number is varying from this mean, okay, that means what? 3 minus 1, 2, 3 minus 2, 1, 3 minus 3, 0, 3 minus 4, minus 1, 3 minus 5, minus 2. Fine. But if you add 100, fine, the mean will become 16. Okay, mean will become 16. Now if you try to do the if you check how much each number is varying from this given mean, now it will be 16 minus 1, 15. Okay, 16 minus 2, 14, 16 minus 3, 13, 12. Okay, and 16 minus 5, 11. Okay, and 16 minus 100. Okay, some 80 minus 84. Fine. So the numbers are completely changing. Fine. So whenever it's in a normal distribution or in a skewed distribution. Fine. So to study how much each number is varying, okay, how much each number is varying from the given mean is also important. Okay, is also important. Okay, that's why we are going to study about this concept. Okay, we are going to study about this concept called as variance. Okay, so that is the fundamental reason of variance. Now variance is what? Variance is, okay, or let me take now, if you try to study about variance, okay, variance is nothing but, okay, variance is nothing but as per the formula. If you go, I will just tell you, average of squared, okay, average of squared differences, okay, from mean. Okay, so average of square differences from mean. Okay, or I can for you I can just put it over here. See, variance is the average of the square differences from the mean. Okay guys, so now if you see what I said, so first of all you should take initially you are having 1 2 3 4 5. What you are having mean is 3, fine. If you take normal distances, okay, what will be the difference between 3 minus 1? 2. 3 minus 2, this is mean guys, this is mean. Okay, I'm trying to find out difference between each and every point from this mean. Okay, 3 minus 1 2, 3 minus 2 1, 3 minus 3 0, 3 minus 4 minus 1, 3 minus 5 minus 2. What is sum of these guys? What is sum of this? First, sum of these numbers?
0.
0. So now because it is 0, can I say there is no difference between each number and its mean? Can I say that? No, I cannot say. Just because we are getting it is 0, I cannot say every number is same as mean. Okay, when it will be 0, when each and every number is exactly same, then only the difference will be 0. That means 2. So 2 2 2 2. What is the mean? 2. What is the difference between each and every point? 2. 2 minus 2 0. Okay, only in that case you will have it as 0. But here in this scenario, since because you are getting 0, you cannot say that every number does not vary from mean. Okay, and but why you are getting? Because you are considering the minus over here, fine. So you are considering the minus over here, fine. So that's why to avoid this pitfall, okay, to avoid this pitfall, fine. So what's happening, do you understand? So the positive distance is getting cancelled or nullified by the negative distance, okay, and that is causing problems, okay, because even if it is a positive number or negative number from the mean, still the distance is distance, right? So you cannot say if this is 2 and this is if 5 is minus 2 and 1 is 2, you cannot say if 2 minus 2 is 0, that means there is no distance at all from these numbers. You cannot say that, fine. So that's why to avoid this, okay, that's why to avoid this, what we are going to do, we are going to do the square of these distances, so that every time it is positive only. Agree? So that's why you are going to do the square of this distance. That means if the mean is 3, so 3 minus 1 2, 2 square, plus 3 minus 2 1, 1 square, plus 3 minus 3 0 square, okay, plus 3 minus 4 minus 1 but minus 1 square, plus 3 minus 5 minus 2 but minus 2 square. Agree guys? So what we are trying to do, variance is, yeah, so it's important to understand what is variance. Variance is the average of the squared difference from the mean. Okay, so why we are studying this? As I said, it is very important to study how much each number is varying from the mean. Okay, you got the mean, and what is the point of mean? It is just trying to represent all numbers by single point. That is fine. Okay, you are just representing with one single number, trying to make justice to each and every point. Mean, that's fine. Average, everything is fine. But after that, it's also important to study that how much each number is varying from this mean. Okay, how much each number is varying. Okay, that is fine, single number, but I should also know what is the variance between each and every point from this mean. Okay, that is what it is called as variance. Okay, and how you are going to get that? It is just the average of the squared difference from the mean. Okay, so squared difference from the mean. Okay, this each and every word, if you try to understand, you will just get the formula. That's it. See, first thing is what? Difference from the mean. What is difference from the mean? Difference from the mean is just the difference. Okay, so what is mean equal to 3. Okay, I'm going to write here x bar equal to 3. Okay, x bar equal to 3 for it. Okay, you got the mean. See, we'll try to understand each and every word so that we'll get the formula. You got the mean. After that, okay, after that you want the difference. What will be the difference? Difference will be just given mean minus it's each and every number. Okay, for the difference, what you should do, it's not the difference, it is a square difference. Okay, it is a square difference. That means 3 minus 1, 3 minus 1 whole square plus 3 minus 2 whole square Okay, plus like that, finally 3 plus 3 minus 5 whole square. Okay, you got the square difference of the mean, you got the squaring of the difference also, you got square of the square also you got from the mean you got, and you should take the average of this. Okay, overall average. Fine, that means what? By total overall numbers, how many numbers, those many numbers you should take. Okay, if n is the total number of numbers. Fine. So if you just convert it into this formula, if you just convert this into the formula, what you will get, each and xi minus mu. Okay, so if you see here, xi is what we are doing, each and every number minus mu. Since, because you are taking the square, even if you do 3 minus 1 or 1 minus 3 will be the same. Agree? Even if you do number minus mean or mean minus number will be the same, because you're doing the square. Fine. So if you see the formula, the variance you denote is by rho. This is called rho square, guys. Okay, rho square equal to xi, each number. Okay, each number, its difference from its mean and square difference, and repeat for each and every number. That means sigma equal to 1 to n and average by n. Fine. So this is nothing but the variance. With this you will know how much, what is the total count of value of each and every number that is varying from its mean. Okay, tell me guys, what's difficult in this to understand? Because you know mean, simply you can calculate mean. You have each and every number, take each and every number, subtract it from mean, square the number, do that for each and every number, sum it, divide by total number. That's it. That's a variance. Did you guys understand the variance? Let me know if there are any doubts. We'll go slowly. Doubts? Clear? Variance?
Yes, sir, clear.
Yeah,
Okay.
so
Yeah.
something like we are subtracting each and every number from the mean and squaring it, sum up, then total number of, here n means total number of that items, right?
Total number of points in your given data set.
So total 5 over there.
Correct, 5.
Okay, done.
Okay.
Yeah.
Fine. So that is the mean. So now by seeing this, you should get a doubt here. You should get a doubt like why it is n over here and why it is n minus 1 over here. Okay, because this is for population, this is for sample. Okay, so now I'm just erasing this. So let me okay, so now if you see here, this is for the population, guys. Population means what? Whole data. Sample, this is for sample. As I said, many a times it is not possible practically to collect the whole data, that means whole population. It is not possible. That's the reason we go for samples. Okay, we take some decent sample from this. Okay, in the hotel, sorry, not the hotel, the college canteen example also, from 1,000 population we took 100 sample. Okay, if you remember. Fine. So if you see the formula will be exactly the same. Okay, the only difference is in population the mean will be called as rho. Okay, in sample the mean will be called as x bar. So here if you see, each point xi minus its mean, okay, the rho whole square, and you are repeating it from I equal to 1 to n by n, and it is denoted by rho square. Okay, the concept is same. Here also you are doing same thing, but if it is sample, you represent it by a square and xi each point minus its mean. Okay, it's also mean. Just representation is x bar whole square, repeating from 1 to n, small n, because it's a sample, by n minus 1, total number of points minus 1. Okay, it's the concept is same, the formula is also exactly same, but only difference is here n, here it will be n minus 1. Okay, but now let's try to understand what is it, why it is n and n minus 1 here. Okay, but the actual reason for this is completely mathematical. Okay, and actually it is out of the scope of this class. Okay, it will go into like deep statistics. Okay, so the reason for n and n minus 1. Okay, but I'll try to give you an idea. Okay, because when I was also studying, I was also surprised like why this is n for population, y will take it n, and y for samples, y will take it as n minus 1. Okay, so okay, but I will give you just an idea what is a relation. Okay, but if you're interested, right, so there is a like lengthy derivation or research that has happened why we should consider n minus 1. Okay, but just for your understanding, okay, for curiosity, the reason for n, okay, and n minus 1 is related to something called as degrees of freedom. Degrees of freedom. Okay, now what is degrees of freedom? It's called DOF. Now degrees of freedom means, okay, degrees of freedom is, see, let's say you are having an equation x plus y equal to 5, guys. Okay, x plus y equal to 5. Okay, so what is the degrees of freedom? How many variables are there here? Two variables. Now what will be the degrees of freedom? It fundamentally means how many variables have freedom to take its values according to its wish. Okay, the degrees of freedom means out of the total given variables, x is a variable, y is a variable, out of two variables, how many variables have its freedom to take any value it want. Okay, I'm saying that, see, so now if you understand my line, I'm saying in these two variables, how many variables have freedom to choose whatever value it want? It will be one. Why? Because let's say x is choosing any value it want. I'm choosing 100. Now what will be the value of y, guys? Tell me, what is the value of y if x is equal to 100?
Minus 95.
Minus 95. Apart from this minus 95, can y take any other value?
No.
No, right? So if x is, but initially I'm taking x as 100. Once x is fixed, the value of y does not have any choice. You are killing its freedom. Agree? But if x, again, if x equal to 2, what will be the value of y?
Minus 98.
3.
No, here in this equation, Siri.
3, Santosh.
Yeah. So it is 3. So now I'm saying initially x equal to 100. Okay. So see. So considering this equation, let me take x and y values. Okay. Now if x equal to simply 5, y should be 0. If x equal to 2, y should be 3. If x equal to 100, y should be minus 95. Fine. So now I am saying, if we are deciding the value of x, you have no choice left for the y. Agree? But for the x, you can take any value you want. Take any value you wish. But once you fix the value of x, then the value of y is automatically fixed. So that means, in other words, you have the freedom to choose the value of x, but you don't have the freedom to choose the value of y. Agree? Same thing goes for y also. I'm not saying x only. So any one variable I'm saying, even if you take the value of, for example, if I take the value of y equal to 0, right? I choose, it's my choice, it's my freedom. Initially, if I want to choose any value of y, I will choose anything. I'll choose y equals 0. But once if I choose the value of y, what will the value of x? It should be 0. Apart from 0, can you take any other value? No other value is possible to satisfy this equation. Similarly, if I choose some value of y equal to some 10, right? So I have freedom doing this. I can do this. But once I do this, there is no freedom for x. Definitely it should go for what? Minus 5. Agree? Getting? So this is called degrees of freedom. Okay, this is called degrees of freedom. And if I extend this example, the degrees of freedom will always be number of variables. Okay, number of variables minus 1. Okay, see, let's try to understand. Let's say if we have x plus y plus z equal to 50. Fine. Now here you take whatever values you want for x, no issues. You take whatever value you want for y, no issues. But once you fix some values of x and y, you don't have freedom to choose the value of z. It should automatically take that value which will satisfy the equation. Agree? Getting? Right? So same thing. You can take any two variables, not only x and y. You can take any x and y or x and z or y and z. Any two variables, you take the values whatever you want. But the third value should be, you cannot take. It will automatically come based upon the equation. Fine. Y equal to 10, x equal to 20. Okay, you can choose my wish. After choosing y also, you can choose anything. That's your freedom, right? So randomly I can choose any value of y. I'll choose 10. Okay, once after choosing this also, I have complete freedom to choose the value of z also. I will choose anything. I'll choose 100. Fine. But if you choose these two, that means two values if you have chosen out of 3, then you don't have choice for the third one. Fine. That means what? Now x plus 10 plus 100 equal to 50. What is this? X equal to 50 minus 110 minus 60. Right? So now you don't have choice for this. So that's why the number of variables, okay, the number of variables, whatever you are having, the degrees of freedom will be number of variables minus 1. Getting? So if you have 10 variables, the degrees of freedom will be 10 minus 1. Okay. If you have 100 variables, the degrees of freedom will be 100 minus 1. If you have 2 variables, it will be 2 minus 1. Fine. So if the actual data is n, fine, the degrees of freedom will be n minus 1. Agree? So this is where they're trying to correlate between the population and sample. Okay, if the actual population is having n values, okay, n variables, if you're considering n, the population which the sample which you are taking from the population, okay, the sample which you are taking from the population should be considered as an n minus 1. Should be considered as an n minus 1. Okay, but this is just an, okay, I'm just giving you a way like why we are considering n minus 1. Okay, but I understand this will not completely justify. Okay, but if you want to go into detail, right, so I can share you some article or blog, so where you will understand. Okay, but it includes like a lot of theory and explanation, etc., which is not required at this stage, and which is also like which goes out of the scope of this or any statistics point. Okay, that goes into research concepts. Okay, but at high level, if you try to understand, so you can try to relate it with the degrees of freedom concept, where you are taking n minus 1. Okay, so same concept which you will be applying here. Population will be always n and sample will be always n minus 1. Okay, so fine. So with that understanding, let's try to come back. Okay, so fine. So that is the reason. I think now you can understand. Why you are having n and why you are having n minus 1. Agree, guys? Is the variance clear? N minus 1. You got the basic idea. Degrees of freedom part.
Yes, sir.
Okay. After that, there is one more extremely important concept called as standard deviation, guys. Standard deviation. Now, from tomorrow class, you are going to hear these two words many times. Now, what is standard deviation? Okay. Now, standard deviation is same as the as a variance. Okay, same as a variance, but as you can see, it is just the standard deviation. It is just the square root of the variance. Okay, so standard deviation, as you can see here, this is just the square root of the variance. Okay, so if, as you can see the notation also, if you are having variance equal to rho square, a standard deviation is the root of variance. This gets cancelled. It will be denoted by rho. Clear? As you can see, standard deviation denoted with rho, but the variance is rho square. Okay, and the formula is also very similar. Formula is exactly the same. Standard deviation is the, if you just put the square root of this becomes standard deviation. Okay, for the population. Similarly, for the sample also, if you just put the square root of here, as you can see here, this will become the standard deviation of the what of the given sample. Fine. The standard deviation is also called as the measure of how spread the values in the data set around the mean. Okay, same thing, but with the square root. Okay, what we try to study over here in the variance and everything, we just try to study one single point. What is the spread of the values in the data set around the mean? Okay, you have like 1 to any number of points. Okay, 100. You are having something called as mean x bar, or well, let's say you call it as mu. Now I want to just see what is the difference of each and every point. What is the spread of each and every point from the around the mean? Around the mean, how much they are spread about? Okay, if this difference is very less, guys, you're trying to understand, right? If the variance is very less, that means the values are very much nearby located to the mean. Agree? If the difference is more, the values are far, because only if the values are far, the difference will be more and the overall variance will be more. Are you getting, guys? If you are taking just 1 2 3 4 5, if you just take 1 2 3 4 5, the mean will be 3, right? And the variance will also be very less. Okay, with that variance you can understand, okay, the numbers are very much closely related to each other. Okay, but if you take like 1, okay, 1 10 20 30, and if you take some mean, okay, and if you calculate the variance of these, the number will be a bit larger. With that also you can understand, okay, the numbers are little more far spread across this mean. Okay, so that's how you are going to understand, and you are going to see with an example so that you will have a better understanding. Okay, but these two formulas are extremely important. Okay, try to memorize these or understand this, whatever you want to do. But the variance is but just remember standard deviation. Okay, we'll just write it. Standard deviation is simply but is nothing but the square root of variance. Square root of variance. Okay, simple. You don't need to again go for any new formula. What first you will see, and all these are related, right? So these are very simple. As you can see, you got a list of numbers, some column. From that column you can calculate mean. Once you calculate mean, ho gaya, you'll use this formula. You got variance. Done. Simple. Once you get the variance, just do the square root of that variance. You got standard deviation. That's it. You got variance. You got standard deviation. Similarly for sample, also for the standard deviation, for the sample variance, sample standard deviations also, you are going to get it. Clear? So fine. I hope this is clear. Now, okay, and now what we're going to do over here is there is one important concept I would like to mention over here, just to correlate with the few earlier concepts. So what we have done, standard deviation, as you can see, what we are using over here, guys, what we are going to using in this what I say, mean. Fine. So but if you remember, mean is influenced by outliers. Agree? Mean is influenced by outliers. So that's why you should be little careful when you are using variance and standard deviation in a data set which is containing outliers, because outliers, mean will affect with outliers, and if this is affected and you are going to use the same value over here, variance will be affected, and you are using the square root of this to get standard deviation, this will also get affected. Okay, so that's why first you should take proper understanding of the data, if the data is free of outliers or not. Okay, so that's why, as you can see, the standard deviation and variance are completely dependent on this mean. Fine. So if this is affected, everything will get affected. Okay, fine. So that's the point I would like to mention over here. And with that understanding, okay, we'll try to, okay, as you can see, same thing, standard deviation formula we have seen, variance formula we have seen. Okay, same formula, nothing different. Okay, fine. So yeah, see, you have time, right, guys? Like more 10 minutes.
No, sir. Going to college.
Going to college? Okay. Fine. That's fine. So tomorrow I'll show you an example. Okay, very good understanding. Okay, but before that, you have just one more formula called as coefficient of variation, guys. Okay, it's called coefficient of variation. Okay, which means that it's just if you do the standard deviation by mean. Okay, if you do the standard deviation, whatever the standard deviation you got, rho or s, okay, with the mean by mu or x bar, you will get something called as coefficient of variation. Okay, so what we are going to do with this and what is importance? Fine. So as we are out of time, we are going to see it in tomorrow's class. Okay, so I'm going very slow, guys, because so that you'll understand the concept. Okay, because my plan is actually to cover to show you an example of this, and also start the concept of something called as correlation covariance. Okay, but I don't want to rush. Okay, because these are the extremely fundamental concepts. Okay, if you don't understand this, everything will be Greek and Latin for you guys. Okay, so that's fine. So even if it takes like 1 or 2 extra class also, that's completely fine, but let's go a bit slowly, at least the fundamentals, so that you will have good comfort levels. Okay, fine. So tomorrow we'll see a few examples of this, and we are going to see like what is the importance of standard deviation and variance. Okay, where we can use that. Okay, and then we are going to see something called as correlation and covariance, which is very interesting and an important concept. And then we are going to see some probability distributions in upcoming classes. Okay, so fine. I hope you guys are following the class. Fine. So as I'm repeating multiple times, if you're not following it at any place, you can stop me and ask me. Okay, so it's for your good. Fine. So fine. Are we good, guys, today?
Yes, sir.
Yeah, Santosh.
Okay, fine. Sounds good. Okay, so tomorrow same time, same link. Let's meet and continue. Thanks, guys.